Hello everyone. Today let's solve the Leetcode problem number 62, unique paths. So what the question says, there is a robo on an m into n grid. Okay, the robo is initially located at the top left corner, nothing but grid of 0, 0. This is fine. Here they have showed in the example. The robo tries to move to the bottom right corner, nothing but this one star. Grid of m minus 1 into n minus 1. The robo can only move either down or right. They have strictly mentioned the robo can only move either down or right at any point in time. So this is fine. Next, given the two integers m and n, return the number of possible unique paths that the robo can take to reach the bottom right corner. So we have to return the number of unique paths that a robo can take to reach the bottom right corner, right? So this one unique paths we have to find. So that this is fine. Example 1 they have shown here. They have given input m equals 3, n equals 7. The number of unique paths will be 28. Output they have given. Example 2 they have given m equals 3, n equals 2. Output will be 3. They have also explained, right? So first let's write the code and try to understand with the example 1. So initially what we'll do, the first one, let's calculate the total number of moves required. Nothing but right or down, right? We have to move right or down, right and down, sorry. So I'll just take let n equals m plus n minus 2. This is fine. Next what we'll do, we'll calculate the number of unique paths using the combination formula. Nothing but the NCR of n comma m minus 1. We have not calculated the NCR yet. We'll write the formula for it, right? So I'll just write now itself, return NCR of n comma m minus 1. So this is fine. Next what we will do, first we will write the function to calculate the factorial of number. Next, after calculating the factorial of the number, what we'll do, we'll write the function to calculate the binomial coefficient. Nothing but NCR, combination formula, right? So first let's write the function to calculate the factorial of a number. I'll just give function factorial of this. Let me take this one, n. So base case will be factorial of 0 or 1 is 1, we know, right? So I'll just make use of the if condition, n less than or equal to 1. What will return? We will return 1. Next, we'll make use of the recursive function. Nothing but we will multiply n by the factorial of n minus 1. Simple, right? Return nothing but n into, when I say recursive function, this one. Let me copy the function name. Let me paste it over here. Factorial of n minus 1. So this is fair. Next what we will do, we will write the function to calculate the binomial coefficient or NCR, combination formula, right? So let me come here, function NCR n comma r. Let me let's return the value of NCR using the factorial. We have the formula for this, nothing but return factorial of n by factorial of r into factorial of n minus r. So somewhere I missed something. So here let's make use of the braces. So I'll just come here, factorial of n minus r. This is fair. Let me format the code and let me hit the submit. Let's wait for some time. So this works absolutely correct, right? So next what we will do, I'll just take the example 1 and let's calculate, right, using this one, the code. Let's try to implement using example 1. So initially what they have given, let's consider this example. M equals 3 and n equals 7 they have given. I'll just write here m equals 3 and n equals 7. So let's come here, this one. Let n is equal to m plus n by m plus n minus 2. Nothing but we'll get 3 plus 7 minus 2. Nothing but here in this case we will get n equals 8, right? So let me write here n equals 8. Okay, this is fine. Next what we will do, the value n equals 8, what it represents? It represents the total number of moves required to reach from the top left, this one. They have showed in the this one, right? Example, top right to bottom right corner, this one, 8. So next what we'll do, we'll calculate the number of unique paths. How can we calculate? Let's come here to this one, return NCR of n comma m minus 1. Nothing but here so just give me a second. Here it is NCR of n comma m minus 1, right? Nothing but n we have got is 8. 8 comma m minus 1 is nothing but 3. M is 3, right? 3 minus 1 is 2. So in this case what we will get, NCR of n comma 8. I mean 8 comma 2. So what we have got here in the second one, NCR of 8 comma 2. This is fair. Next what we'll do, we will calculate NCR of 8 comma 2. For that one what we'll do, first we will come here, this one, to the factorial. So what we have, first we will calculate the 8 factorial and then we will calculate for the 2 factorial. Nothing but here, if you can observe, return n into factorial of n minus 1 is nothing but 8 minus 2 factorial we'll get. First we'll calculate 8 factorial. 8 factorial is nothing but we will get, we can calculate, we'll get 40,320. This is fine. And this one, 6 factorial, I mean 2 factorial, we get 1. Nothing but 2 into 1, right? So, sorry, it will be 2. 8 factorial is 40,320 and 2 factorial is nothing but 2. Finally, 8 minus 2 factorial, we will calculate by using this one. 8 minus 2 factorial is nothing but 720 we get, right? 8 minus 2, this one, factorial is nothing but 6 factorial. 6 factorial, we will get 720. So finally what we'll do, now 8 minus 2 factorial, we got 720. 8 factorial is 40,320 and 2 factorial is nothing but 2. Now finally we'll come here, factorial of NCR, n comma r, nothing but 8 comma 2. Just give me a second. NCR of 8 comma 2 we will calculate according to this formula. Factorial of n is nothing but factorial of 8 and by 2 factorial into 6 factorial, nothing but we will get here 40,320. Next we will get by 2 factorial into 720, nothing but total we will get 40,320 by 1,440. So here when we apply this formula we get 40,320. So here let me come 40,320 divided by 1,440. So when we apply the NCR formula, this one, return factorial into n, a factorial of n by factorial of r into factorial of n minus r, this one, n minus r, this one. So this one will give the product, this one, we get the answer 28. Nothing but the answer that we got here is, the output is also 28. The answer that we got here is also 28. So the code works absolutely correct. So let me delete this one. So what we have done here basically, we have imagined a grid with 3 rows and 7 columns. The example, this one, we started from the top left. We moved to make 2 down moves and 6 right moves. So the number of ways to arrange these moves is these moves is the binomial coefficient of 8 comma 2. Finally that we got this one, 28, answer 28. So the code works absolutely fine. So what will be the time complexity and the space complexity? So let me come here, just give me a second. So the time complexity would be big O of n, where n is the maximum value used in the factorial calculation that we know here, this one. n is the maximum value used in the factorial calculation. So the overall time complexity of the unique path function would be big O of n. So the time complexity I'll just give here big O of n. What is the space complexity? The overall space complexity is also big O of n. Why? We are making use of the recursive calls. You can see here factorial of n minus. We are making use of the recursive function, right? We are making use of recursive calls in the factorial function. Since the depth of the recursion can go up to n, the overall space complexity would be big O of n. Let me write here, space complexity would be big O of n. So let me comment this one. Let me hit the submit again. So this works correctly, right? So this is it. Thanks for watching, guys.